Students, now I am here to explain this unit 3 part 2. So just I will go step by step. Flipped model, it's traditional flipped model. So now I am going to discuss about structural behavior of materials. So let me explain what is the structural behavior of materials. In structural behavior materials, we will discuss about the concepts in equilibrium. So you already know what is dead load and what is live load. So you can read these things, what is dead load and what is live load, how it comes and how they impose load, and what are the types of dead loads and live loads. So again, what is another wind load and types of other loads. So I want to concentrate more on these types. What are the natures of loads? Point load is called a concentrated load, such as a column supported on a beam. So if you see here, this point load is, point load means it is a concentrated load such as a column supported on a beam. If you see here, it is we have a beam here, a column is supporting on the beam, it is giving a point load. This is point load, uniformly distributed load. So if you have a beam like this and it is distributed uniformly, so the beam, the total length of the beam has been imposed by a load, it is equally distributed. This is uniformly distributed all over the beam. So the beam's own weight, the weight of the floor slab it's supporting, and the live load supported by the floor slab are consistent all the way along the beam, all consistent along the beam. This is point load and uniformly distributed load. Next one is uniformly varying load. It means the varying load itself, it shows that the load is varying. So here the load is 0 and here we have maximum load. So for minimum to maximum, the load is varying at different parts of the beam. This is called as uniformly varying load. A uniformly varying load is a load that is distributed along the length of a linear element. A common example of this is a retaining wall. So what is a retaining wall? Generally we have some landfills which are constructed by the retaining walls. So this wall will retain earth pushes horizontally at back of the wall. Here all the part is filled with some landfill, some soil or sand. So this is called as retaining wall. So what are the types of supports? We are having different types of supports. Support is the connection between the structural element, such as the connection between columns and beams. The first one is roller support. This type here we can see a roller support. So we have a support, these are having movements. See, roller support is having the vertical force only, it can resist only the upward force. Roller supports. A roller support to a part of a structure is analogous to that person on roller skates. It is simply like we have roller skating shoes. The person standing on the roller skates, what is the force he is having? The same thing happens here. A roller support is free to move horizontally. It can have a movement in a horizontal direction. In practice, a roller support might comprise sliding rubber bearings. For example, steel rollers between steel plates. You can observe this type of rollers in bridges constructions. You can read more later. A roller support provides one restraint. So it can only restrain vertical reaction. So this can no horizontal force cannot be supported. We have a free movement. So we have a restriction in vertical movement. So roller support will have horizontal movement but not vertical movement. So here an actual roller support. This is a bridge and we have some roller supports. This beam can move in horizontal direction, but it is fixed in vertical direction. Next support is pinned support. What is pinned support? A pinned support permits rotation but cannot move horizontally or vertically. So you can see, if you have a pin and if you apply a small channel or something, you can rotate in clockwise or anti-clockwise direction, but it cannot be moved in horizontal or vertical direction. In exactly the same way as a door hinge provides rotation but cannot itself move from its position in any direction. The example of the pinned support is our doors. We have door, we can move, open the door and close the door. That is pinned support. A pinned support provides two restraints, vertical reaction and horizontal reaction. So this can restrict movement is only in rotation wise. So it cannot move in vertical direction or it cannot move in horizontal direction. So another types of supports are fixed supports. We have some fixed support, means the support is fixed. So this is roller support and this is fixed pinned support. So it is restrained in vertical direction, it is restrained in horizontal and vertical direction. So there are many situations in practice where it is necessary for a beam or slab to be supported at one end. For example, a balcony. A balcony is a best example of a fixed support. In these situations, the single end support must be a fixed support, because a fixed support cannot move in any direction from its position, cannot rotate. So a fixed support is fixed in every respect. So it cannot move in vertical direction, it cannot move in horizontal direction, it cannot move in rotational direction. So here it is restrained to vertical direction, vertical reaction, horizontal reaction. Rotation force means moment, it is fixed with, we have some moments here. So a fixed support provides three restraint. Restraint means it is fixed in the direction, vertical reaction, horizontal reaction and moment. So this is important slide, equilibrium. So we know this, every force is having its equal and opposite reaction. So for every action there is an equal and opposite reaction. That means any force on it must be opposed by another force, equal in magnitude but opposite in direction. If you apply some force, it is having some resistance towards that force, that is called as reaction. You can see here their force, this force and this force is having, this is similar to this. If you are pulling it, it is showing some reaction, that is known as every force is having equal and opposite reaction. We are having three equilibrium conditions, these are very important, you have to keep all this in mind. Vertical equilibrium, that is sigma V. What is sigma V? The directions in vertical direction, total upward force is equal to total downward force. How much force is applying from the top direction, it's the same thing, reaction is happening from downward force. So if you have opposite upward force, the same will have equal force. So these two are same. So we say that sigma V is equal to 0. Total upward force is equal to total downward force. Horizontal equilibrium, that is sigma H, that is total upward force is equal to total downward force. See this here, arrows are in left direction and right direction. So horizontal equilibrium equation. If you come here, moment equilibrium, that is sigma m is equal to 0, that is total clockwise movement is equal to total anti-clockwise movement. Total clockwise movement is equal to total anti-clockwise movement. You can note it, a moment is a turning effect. A moment always acts about a given point and is either clockwise or anti-clockwise. So moment can be in clockwise direction or in anti-clockwise direction. So what is the application of equilibrium? So I'll tell you simply this, we have two supports here. we have a beam here. There are three forces acting on it, F1 and F2 and F3. These are the reactions. These are the upward forces, these are downward forces, and these are the upward forces. These are the reaction. This force is having equal and opposite reaction. So F1, F2, F3, these are generally called as, this one can be noted as R1 and this one can be noted as R2, R1 and R2. So how much force is taken by these two reactions? What are the reactions at these supports? So this can be calculated as, if you take F1 as 5 kilonewton, F2 as 10 kilonewton and F3 as 15 kilonewton, then the reactions from this R1 and R2 can be the sum of all the totals. As we discussed, the total downward force is equal to total upward force, that is R1 plus R2 is equal to 5 plus 10 plus 15. So that is R1 plus R2 is equal to 30 kilonewtons. If we want to know this R1 and R2, the sum of this R1 and R2 will be the sum of this total loads acting on the beam. So here I want to explain a problem to you. This is the activity also for this class. I will explain this problem here. When you come to the class, I will change this numericals and give you in different way. You have to find out this, you have to do this activity in the class. So please concentrate and learn, try to understand it. So it is a concentrated load. Concentrated load is also known as point load. Here we have a beam, that at B we are having roller support, at A we are having fixed support. The length of the beam is from point A to this load, the length is 4 meters. From this load to B, the length is 2 meters. So A, where the point load is acting, is called as C and B. From A to C it is 4 meters, from C to B it is 2 meters. So the three rules of equilibrium can be used to calculate reaction. So we can use the equilibrium can be used to the three rules. What is three rules? Sigma V is equal to 0, sigma H is equal to 0 and sigma M is equal to 0. So first let me explain this. From vertical equilibrium we know that total force upwards is equal to total force downwards. So total force upward is equal to total force downwards. From the previous slide you can see R1 plus R2 is equal to total load acting on it. So here simply we can take RA, at A it is acting, we can take this as RA, at B it is acting, we can take it as RB. So RA plus RB is equal to 18 kilonewtons. So RA plus RB is equal to 18 kilonewton. From moment, this is from vertical equilibrium condition. If you take from moment equilibrium condition, we know that the clockwise movement is equal to the total anti-clockwise movement. Total clockwise movement is equal to total anti-clockwise movement. So the above applies at any point in a structure. So taking moments about point A. So taking moments about point A. So I'll explain you this on the board. I think you can feel comfortable when I explain this part on the board.